Okay, good morning, everyone. Welcome to day 2. Today we're listening to Everycook by Alexis, also known as Better Food Through Information. At the end, we'll have about 15 minutes for questions. Please give him a huge round of applause.
Thank you. So the idea of Everycook, as I wrote it, is better food through information. We want to have a concentration of data using recipes, but we want digitally specified recipes. So we have degrees Celsius, we have pressure in bar, we have grams. So it's a mathematically precise recipe. We want all kinds of food. Every farmer growing something should be inside our database, so we can link the ingredients of the recipe to where do I get the ingredients to cook that recipe. We also want information about health. So what are the nutrient values, how many cholesterol has it in, how many carb, and so on. And all information about nature. How was this food grown? What is the impact on our planet? And these data could be used on one part in machines in the Web of Things. We have built one first machine that can read these digital recipes and cook after it. So the machine already knows what temperature to set for how long to cook or how many grams of an ingredient are coming. So you can make an interactive scaling. You don't say the people 1 cup of rice, you say just give me some rice, oh stop, that's enough. And if we have this data, going to smartphones and tablets is quite easy and is for all people who don't want to have a big machine in their kitchen or who can't afford it. They will just get a very interactive cooking assistant on any HTML capable device. So I'll talk about hardware, then software, about the data, the opportunities, and some needs we have identified that are necessary to push our project further. So the problem, that's how it started. Oh, I just do a quick mail check, oh, damn it. And the industry makes us, for example, rice cookers and deep fryers. What's the difference? If you take a deep fryer, you just throttle down the heat a bit, you have a rice cooker. And if you make a pressure-tight lid on it, you even have a pressure cooker, because it's all just a heated pot. We just need a different regulation. Electronics are not expensive anymore. Most devices have some knobs and strange interfaces. We want, of course, a digital interface that is interactive, that tells the user what to do. And an Arduino is easy to program, so it's not difficult. Analog is nice, programmable is even better. But wait, if we have the Arduino or if we have some kind of data reading device, then we can add more sensors, we can add a timer, think if then else. If the temperature starts to rise, we have probably no water in anymore, so the rice is cooked. The rice cooker works like that. If the temperature starts to rise, it makes click and goes into warming mode. We can do that by software. And we could even start talking to the user. Text-to-speech is existing, is open source, and we have texts. We have even a speaker. Our last machine is built based on a Raspberry Pi, so we have a sound card. We could even talk to the user. Talking is exchange of information. So what information could we use? Yeah, we want all information, and we want the machine to be online to exchange the information from a central database where we have the nutrient values, the cooking times, and so on. But we also want to share data from one machine to the other. If we have a recording mode, someone cooks, thinks, okay, it's nice, I have recorded it, it took so many minutes at this temperature, so many minutes at that temperature, and so many grams of each ingredient. Okay, it works, let's share it, and everyone else can download it and cooking even they have never cooked it before. In 2008, I had a first idea. In 2009, I was working mostly on CAD, thinking what sensors, what else could it be, and so on. 2010 was interesting. I had first talks to manufacturers. They said, yeah, it's interesting and so, but they mostly don't believe in the Web of Things. They don't think a kitchen device should be online, should share data. So I got, mostly advices, but not one saying, yeah, we push that. That was the first prototype. Yeah, that was the support. Based on the support I got from one manufacturer, he gave me the pressure cooker. And I said, okay, now I need a chimney where I can put in the carrots to cut them, because I want to be able to cut. So that's the chimney for the carrots. In behind we have the motor. This down here is a load cell. This is just a conventional induction stove with some optocouplers. I pushed the buttons coming from Arduino. This was also directly read with an Arduino, and somewhere here in between I had a temperature sensor. It worked. I had a Swiss business angel looking at this. I told him, I had some contact to him, and I told him I'll come back when I have a prototype. And he said, okay. 1 day later I came with this, and he told me, you shouldn't have shown me that. It looks dangerous to investors. But what did I learn? The motor I just got from somewhere, I don't remember, is just too heavy, and pulling it out vertically and putting it out by side is uncomfortable. We need a hinged cover so the motor stays on it, and a faster motor, and the blades, I sharpened them by myself, and after 2 times they were already not cutting anymore. 10-bit on the ADC of the Arduino is bad, not enough. Pressure sensor, I did not have a pressure sensor. You can do some calculations. What is the temperature of the boiling water, and what's the ambient pressure? And then you can calculate what is the overpressure you have in the pot, but no, we want a pressure sensor. And the hacked induction heater I had is a black box, no idea what's going on. The database was just a bunch of text files, so we had to redesign it. PHP was also quite bad. And I found later on a good coder who helped me. Then the next generation came. Now in a CAD picture on the top we have the motor. We have, of course, safety valves on the cover for pressure cooking, pressure sensor, Wi-Fi in the back, web server on an embedded computer, so we just can use directly. No, the idea was we program the whole database in PHP, and we could now reprogram the whole thing for embedded user, but we didn't have the capacity, so we just copied the whole stuff on the machine, and now we have the PHP running on the machine. In here, there's a cutting disc with the chimney where we can put in the carrots, a stirrer that stirs in the pot so it doesn't stick, temperature sensor, induction heater, scale, as I said in the previous model, but this looks less dangerous. So, and I found expensive blades from a professional machine I could adapt, so they were sharp. I used the Maple Mini 12-bit ADC, still not enough, but it was already better. An embedded PC, the first machine had a EEPC just standing besides, connected to the Arduino, so that was not visible on the picture. Now I have the PC inside. Somewhere joined the team, or the left, And Samuel is now upstairs. You can meet him later on. He's coding. And he helps me so much doing the whole PHP and MySQL stuff. And then I produced it. It looks much better. It looks like this. It's standing upstairs in F2. We will cook today on this because it works. The next generation is close to working, but not perfectly. What did I learn from this machine? Raspberry Pi would be great. It's a third of the size of what I have now inside, and also a third of the price. And it has GPIO, so I can directly connect ADCs and stuff. 12-bit is not enough. I had an adjustable op-amp, but I was fiddling with these gain and offset, try to be inside these 12 bits. And finally, I just had four load cells, 4 different gains, and so having a precise scale was nearly impossible. The open source hardware induction heater still has some bugs. Sometimes it doesn't start oscillating. Con is sitting here. Hello, Con. He is the high power guy. He helped me to make induction heating, which is pretty interesting. If you want not having 30 or 40 amps on the input of the whole system, you need to come in with 230 volts. Then you rectify it, you have 300 volts DC, and then you start making an oscillation. And this oscillation easily goes above 2 kilovolts, and the transistor we have inside is rated to 1.2, so we blew a few of them. Makes pretty loud noises when they explode. And flying bits and stuff. But Con got it to get that oscillation stable, not going over the limit of the hardware. And now we have between 1.5 and 1.8 kilowatts of heating power on our coil. But the base was good, the case and so had some minor changes. And then I use now a 40-bit ADC, 24-bit ADC, sorry. And with the 24-bit ADC, I have so many bits, adjusting the offset is not an issue anymore. Either I am on this end of the range or the other one. I can always read a signal, I can reprogram it. It has an integrated amplifier. So over SPI, I can change everything precisely. So the readings from the scale are now much better. Someone learned how to contact the ADC. There's lots of registers to set it. I had connections to China to get just the bare induction board. First I thought we could make the open source boards, but then I didn't have the coils. Just a simple coil, wound copper wire. If I try to buy it in Europe, it's a spare part for some fancy induction heater. It costs me $100. So, and then the homemade board will cost $50, and the finished boxed black box costs me $30. So I was thinking about, let's just rip them apart, take out the coil, take out the power electronics, and do what I did in the first machine. It's a black box, but it's self-contained, it works, and yeah, it's the open source versus circuit bending approach. So now we are back to circuit bending, but we still try to get the open source induction heater running. And we made a special Raspberry Pi shield, so we had much less wires. We had the ADC and the PWM chip directly over the Raspberry Pi, and we connect all wires on it. It's all upstairs. You can have a look. So we want the most intelligent cooking device, so we need software. We want, what is intelligence to us? We want to minimize the input from the user. I spent so many times with the recipe book and the scale and the mixer, and then you look at the book, 100 grams of flour, you fill it in, then you lose where you were in the book, and you're just always back and forth until you have just all ingredients scaled for the cake you want to bake. So this we want to minimize because the machine already knows what to do. but we want to maximize the interactivity. So scaling, for example, is a progress bar. You have reached 100% of what you say you want to cook. 100% is much easier than 125 grams or something like that. And we want a time planner. If you do several things in parallel in the kitchen, for example, risotto and some meat, the meat is the last thing to put in the pan, usually at the right moment, because if you put it too late, your rice will be glue, and if you put it too early, your steak will be rubber. So you just need the right timing, and because we have all data, we need the data for the machine, then we can also make parallel processes. Okay, now your first part is all set, concentrate on the meat, or don't forget to put the water for the pasta. And then we want to help beyond cooking, so shopping, where do I get organic food? What is health? Is it fat, or is it high carb, or does it has the fibers or whatever? And sustainability, where does it come from? Is it the potato that took the plane to come to me, or whatever? And sharing with other users. The platform is pretty simple. A MySQL database, a PHP, JavaScript on the browser side, and with that you can already make a lot of interactivity. For mobile use, it's not so great, because as soon as you have no internet anymore, the interface is stuck. So the next step will be to add more abstraction layers, so we can push whole recipes to the device and play them directly from the device. The cooker, the old cooker was, we had from the MySQL on the embedded PC, going over the FTTY USB 0, the serial port, to the microcontroller. The microcontroller then had contact to actors and sensors. This was the way with the Maple Mini. Here we have directly the ADCs on the microcontroller, but as I said, not enough bits. But this has the advantage to be real-time. The microcontroller is not multitasking. He's very precise in timing. But wait, we are cooking. We don't need that. So for the next version, it was much easier. Raspberry Pi, GPIO. We have an SPI ADC with 6 channels for reading sensors. We have a PWM chip with 16 channels for actors like displays or the motor, or we have a servo that opens up the pressure valve. This is all over the PWM, and some last actors are directly on a GPIO port, like a beeper, where I just say power, make a beep. That's easier if I hook it up directly. So what do we want to know about the food? Whatever we can get legally. So, and there's so many informations available about food from non-governmental organization, Greenpeace, WWF, and we have nutrition websites, people that have diabetes or other diets to respect. They all have their homepages. They are all collecting data, but it's very unstructured. So for the recipes, that's the most difficult part, because we will have to rewrite every recipe to be machine readable, but from that we can evolve a lot, because if you have one standard pasta sauce, you can just take it and add one more ingredient. My vision is a drag and drop recipe creator. Oh, I want to add pepperoni, let's add that much pepperoni at that time of cooking, based on a template. And so you can, if you have a few base recipes, you can rapidly make many more. And yeah, we need of each ingredient the weight to be able to calculate nutrients. We need the time of each step. Even a rough estimation, peeling carrots, is difficult to have a time for this, but it helps you a lot if the machine already tells you, or the interface tells you, hey, wait, you have 2 kilograms of carrot, you want to peel. you won't do that in 2 minutes. So think about it, that you will take 15 minutes already peeling the carrots, and if the steak is in the pan, it won't come good. So that's why we need times. And for stirring, we take RPM. This is a physical unit, how many rounds per minute our stirrer does. And we have a run time and a pause time because we want to be able to make interval mode, not continuously stirring, but stirring for 3 turns and then wait 30 seconds and then stir again and then wait again. So you don't mash the food, you're just keeping it from sticking. But these are times in seconds. And the step mode tells the machine what's coming, what it has to regulate. For example, there's the mode pressure cooking, which means pressure cooking at that pressure. So you watch the pressure sensor and regulate the heat to keep the pressure stable. If you have normal cooking without pressure, you do the same with the pressure sensor. If you have a scaling mode, then you say, okay, we want to scale now, we want to scale 100 grams. The machine goes into scaling mode, and as soon as the weight is reached, it makes a beep, and continuously it sends to the interface the status, so you can make the progress bar. And for this, we also increase the communication speed a lot, because scaling has to be fast. It's the only thing that has to be pretty fast. I think 10 frames per second, so at least 5 should be possible, so you continuously see what's inside. It's nothing, I have kitchen scales, you put in, you wait, oh, I have this, oh, damn it, too much. No, that's, so for interactivity, scaling must be fast. Communication format is JSON. That's a standard that's accepted. T0 is the first temperature sensor, P0 is the first pressure sensor, M0 RPM is the motor RPM, M0 on is the on time, so 10 seconds of stirring. M0 off is the pause after the stirring, so you could say 20 seconds. If you make 10-20, it stirs 10 seconds, then it waits 20 seconds, then it stirs again for 10 seconds. W0 is the wait that's coming, step time is the time, the mode as explained, and the step ID is just that we have a running number over all steps, so the interface and the machine can look, is the step finished, is the next step coming. And if we have it in JSON, we can directly read it in JavaScript to make an interface. Then for the ingredients, we have attributes like, is it fresh, is it dried, is it frozen, how long can we keep it? We have a link to nutrient data, and we have a link to products. So we have an onion, and we have a link to the nutrient data, what's inside this onion, and we have a link to products like the organic onion or the non-organic onion or whatever, and then from there we go then to the shops, where can we get it. Nutrient data. The best nutrient data I could find come from the US Department of Agriculture. They make it freely downloadable on their website. It's a database with about 7,000 rows and 40 columns. So for each ingredient in there, we have 40 different values, all traces of metals and calcium and stuff, of course, all carb and saturated fat, non-saturated fat. And this data was available, so I took it. The Swiss database, now I heard it is online, so we will try also to integrate it to have the most complete database. But because every country has such a database, every country has some people researching about food. A lot of universities are researching about food. Mostly this data is somewhere hidden on a server, but we will try to get more and then connect it to diabetes, allergies, sport. If a sports guy says, I need 4,000 calories a meal because I'm a cyclist, then he can easily calculate his diet. The products, yes, we need to buy the food, unless we grow it ourselves, but most of us still buy it. So everyone who is selling or giving away food, if someone grows just too many zucchinis and knows I will never be able to eat them, he can just put it on our database, and together with the GPS tag, these zucchini are here and are to be eaten. And if someone just says, oh, I want to eat something with zucchini, or I just can pass by, and the food won't be rotten, it will be eaten. And we also want to accept food that is not accepted by supermarkets. A cucumber like this is still delicious, so why throw it away? The supermarket says we can't stack it in our boxes, or the consumer won't buy it. I don't care. I think there's a lot of people, especially big families or so, if you tell them it costs half the price because it looks a bit different, because it's a heart-shaped potato, for example, they will say, okay, it's great, I can feed my kids for half the price and the food won't rot. So we want to make this link. We want to validate and to have some quality criteria about this food. And we want to connect us to many organizations that do some kind of classifications. There are, I call them ethic criteria. Maybe it's a difficult word for this, but is it vegetarian, vegan, is it halal, is it kosher, is it Hindu, whatever. This is, if someone knows, I can say this fits into this category, then we fit it into this category and other people can find it based on that. If we eat meat or fish, we want these animals to be happy, to be not coming from overfished seas, or not be or dolphin safe, or however. I think this data is also available. I have seen websites from WWF, for example, who tell you this is good fish and this is bad fish. But if I have a recipe here and a website here that tells me what food I could use in that recipe, it makes it complex. I don't want to serve 3 or 4 websites to have a good meal in all aspects. And so we want to make a kind of badging system and have a community that controls the ones who want this badge. So if someone says, my food is organic, wait, you can't just tell it's organic. Is there someone who confirms that it's really organic? Then where to get it, these products, then we need shops, and these shops now, they will get the GPS data so we can easily find them. That could be the farmer himself, that could be some small shop, small independent food shop, some market stand, an online shop. It could even be a supermarket of a big international company. Why not? We take everyone, and the user can choose what he wants to see. If he says, I don't want to see the big supermarkets, I only want the small shops, he will only see the small shops and he will get his food from there. If someone says, I have a supermarket in front of my door, I don't have money this month, I want it as cheap as possible, this is also a criteria, so he can get it that way. The data, an overview. We have the recipe, as I said, 30 grams of onions, 5 grams of olive oil, 1 minute at 100 degrees, mathematically precise, connected to the hardware, connected to the ingredients, connected to the products, and also as an alternative to the hardware, just an interactive app that tells you now you need high heat or low heat. It's not really precise, but it's already a great help. And here I said these are the 2 processes. It's a bit difficult, I think, to see, but we have 2 progress bars. For example, your pasta is at this point, your meat is here, so you should hurry. If you want to get your meat at the same time finished than your pasta, or we will have some delay, but then you know what's the next urgent thing to do, that my guests will get food at the finishing time. Opportunities. I have already many ideas of opportunities, but I think that we can do even more if we have this digital base, these this interface where we can connect all kind of other devices. We could just make a simple kitchen scale that is interactive and calculates the nutrients. So you fill in and it counts calories. Doesn't exist until yet, and that would be a Raspberry Pi and our Shield. A very simple device. You could make the same with an oven, a stove, however. And I think what I've not done yet, or only partly with the induction cooker, but that's a thing I have to try, is circuit bending on existing machines. Thermomix makes a cooker that stirs and cuts and heats and even has a scale inside, but the interface is crap. It's many, many buttons and such a small screen. I say no, I want the opposite. I want a big screen and no buttons anymore. One button, the emergency off. Jamie Oliver also launched some kind of stirring and heating machine. It's called the home cooker. Costs about $500 or so, $600. At the last IFA, they were presenting that as the greatest, newest invention. Also here, we could put a Raspberry Pi inside or put an Arduino inside and make it much more interactive and intelligent. So yes, as I said, competitors to Thermomix, I talked about the Philips home cooker which is launched with Jamie Oliver. The Kenwood Cooking Chef is a really big Kenwood cooking kitchen robot, and down here they have put an induction heater. It's great. We can heat and we can stir. That's for many products, for many recipes, this is important. But the manual tells you, turn the heat to 90 degrees, and if the machine tells you we have reached the 90 degrees, then set 3 minutes. Sorry, it can't be. If we reach the temperature, we directly start counting the time. That's 2 lines of code. And on the software side, text-to-speech, as I said, is not implemented yet. Could be done, a route planner for shopping. If I want to buy at the local farmers and I have to go to 3 farmers, it may be complicated. But it is a nice day outside. I want to make a cycling tour, so I make a cycling tour, and it just tells me, okay, you have to go to 2 farmers and you can cook your meal. Then I guess that the supermarkets will be the last to give us some data about what they have in their shelf. Because this is some kind of secret. Sometimes they try to, in a smaller supermarket, they just add the expensive products. So you have to buy the expensive one, and in the bigger one you have the choice between expensive and cheap. So I'm not sure if we really get an interface to their SAP or whatever, to their big database. So we could do the opposite. We just make an app, and if someone buys something, he just takes a picture of the barcode and of what it is and adds it to our database, and then we can tell the people, look, if you just need a can of tomato or a bottle of olive oil, you will find it there, because until now we work with some assumptions with some data we have now, and it already fooled me. I thought, okay, I go to that supermarket, buy this, damn it, it's not here. And so that would be, if we don't get the data, we will take it. And I'm not sure, but I think we won't get sued because, okay, we have some copyright violation. If we take a picture of Barilla pasta and put it on our database, Barilla could come and sue us and say, that's our logo, that's our right. But on the other hand, we make free publicity for them. I don't know, I'm ready to try it out. And CO2 and water footprint calculation is also, lots of studies have been done, what is the footprint of a kilogram of that food. So it could be integrated, special diet plans for special patients, and so much more. What we need, we have one web programmer. He spent a lot of time, but there's still a long wish list of what could be implemented. The whole stuff is on GitHub, so we can fork it. Whoever wants can help. On the hardware side, we have the daemon reading the sensors and controlling the actors, which works, but it's not really nice yet. And the design is not beautiful also. So, and also we are in prototype stage. So from the prototype stage to something that is really safe and looks nice, we could need help in all fields. Nobody works for nothing, usually. So fun and challenge, that's exploding transistors and stuff, or trying out to make interactive web interfaces or the best design and so. And we can, if someone is really engaged, find a way that he gets some shares in our startup. But the last money went into the machine, so that's very difficult. And if there's an investor that says, okay, we have no patents, we have no real intellectual property, the data, I heard of a lot of people, protect your recipe data. I said, okay, I want to have an internet connection between the machine and the database, and yes, the MPAA proved that protecting data is very easy. No chance to protect the data. So if I have my database, probably someday someone will come and make another device which I can't control and will just take my data. But for me it's good, because it gives me it gives me feedback. I see what recipes are liked, is my data complete? So no idea if I ever will find an investor who, with these issues, ever will invest. But that would be the other way to solve what? To solve all the problems is having big money and hire people. No idea. So our core team now, that's myself, Samuel, who you'll meet later, Charles and Konradin. Con, I mentioned that's the high power guy. Charles is just besides him. He's a great cook. He's going to cook today. And he helped me a lot how to define recipes, what are the different cooking modes, and so on. So that was it. Thank you for your attention.
That was rad. I think that might save me from my own cooking. Thank you. Okay, people are already lined up at the microphones. If you have questions, please line up there or there. Thanks.
Hi, thank you for this very interesting talk. One question which is probably very obvious: why don't you go to Kickstarter? Because I can't solder. I'm very interested in that, so shut up and take my money.
I thought about it. Kickstarter is next. Kickstarter is next. I hope I do it in the first quarter, or at least in the first half of 2013. I still have some issues on the current hardware release, which I tell them, no, it's not perfect, not really ready yet. But I have cases for 10 machines. And if I have these 10 machines running, then I give them away in a Kickstarter program and will make a lot of goodies, and I can start cooking. I thought a nice goodie would be some jam, digital cooked jam and digitally cooked fudges and stuff. I have many ideas about Kickstarter. I will do it. Yes.
Do you have plans to work with dietitians to make food ontologies or to scrape recipe data? Because there is an ontology in schema.org that also contains recipes. I don't know how useful this is, because you get the data, oh, this is RDF data for a recipe, and this recipe has a connection to another recipe, but I don't know if you can derive how to cook it from this. Do you work with these people who make these ontologies and tell them?
Not yet.
Put it in? Okay.
Not yet, but I hope you can establish the contact. Or at least give me a link to their page, and so many informations, and this I would love to do this full time, but I have a wife and the kids, so this is besides my job, so all these contacts are to be made. Thank you for the input.
One really serious question is how do you go about cleaning this thing? Because you know we all know about pots.
Of course.
You know, we all know about pots standing around and just being dirty, and we don't want to clean them, and we can put this thing into the washing machine or in the dishwasher.
I'm a mechanical engineer. Whatever goes in a dishwasher is stainless steel.
Yeah, but still, it's quite a lot of electronics, and if you
No.
like kitchen...
Do you have a rice cooker?
No.
The rice cooker is, you have an inner shell, a pot.
Yeah, but if you
take it out.
Yeah, but if you
I was wondering where the, sorry.
No, but if you actually you have the lid. At least you have the lid that goes dirty when you really cook something that's really hot.
That gets some splatter, yes, and that's. I think in the next generation I will have an inner cover that the dirty part that will be washed. For now it's a bit complex because from now I can only do flat things. It's all laser cut aluminium, which is the only technology I can afford. But for the next step, the lid is the main issue, you're right.
Okay.
Hi. Have you thought about emergency procedures? So if I put too much salt in it and the machine recognizes it, that you said, okay, you put 100 grams of salt, you should have put 1 gram, so please put this and this to make it an eatable meal?
Yes. To be done. We thought about it, but yeah, first we need just with a normal user to get good meals, and then then we can try with the drunk user. Sorry.
Hi. Over here.
Sorry.
I was wondering if there's a way you have to consolidate recipes, because if you ask 50 housewives how to cook tomato sauce, there will be 50 recipes, and maybe you have 70. So if you have, say, a voting system like this is the best tomato sauce, or a cook, he will tell you this is really a good way to cook tomato sauce, this is a bad way. Is there something, or have you thought about it?
We thought about it. What I would like to implement an approach is that you have some personal recipes. You can take a recipe from a pool and personalize it, adapt it somehow, and then maybe reshare it and say that's better. And I see what recipe is cooked how often. So I think the rating, I would prefer to do the rating by clicks than to add 5 stars. Nobody is going to fill out. Because I know it from myself. Oh, please rate. And if it's really, really huge and great, then I give 5 stars. And if not, I don't think. So I would do the rating about how often a recipe is used, and try to make variants. And this is to be refined. But I think I will do that with the users, and by now the software is not good enough to have many users.
Oh.
So that's, work in progress. But thank you.
Thanks.
Hi. Yeah, actually I wanted to ask if you want to do some kind of a wiki approach or something, but I think you answered that already.
Yeah.
So I will answer, you showed us this prototype from 2011 and said it works. How did it taste?
Great. It took me 3 iterations to get it good, but that's the good thing about digital cooking. If you see, oh no, that's that's overdone. Okay, I reduced the time by 1 minute. Oh, now it's close. Half a minute less, now it's perfect. And so after a few iterations, you have it. And if you control the temperature, you don't stop stirring, what can go wrong? The proportions are also right because you have scaled everything. It tasted well.
Okay. We have a couple questions coming in on IRC. I'll pass that on.
Can the software be used without the machine? So we make everything ourselves and the software just tells what to do.
Without the machine, yes. That's the first, on the first picture. Maybe I'll go back to that, yes. That's the smartphone and tablet way. So if we have all the data in such a nice way, we can send it to a machine. We can make a great interactive interface, do this now, or wait with this until in a few minutes to get the timing right. And there will be short, step-by-step instruction, just one sentence, do this, not long texts where you lose where you were. So yes, without machine it's possible.
There's another question from the IRC. How about a recording mode if you want to experiment and record what you have done?
It's planned.
Have you really considered the safety and security implications of having a 2 kilowatt motorized electric heater connected to the internet and running PHP in your house?
I have many people who say me, oh, that's great, I can start it if I'm on my way home. And I told them, no, probably not. Because, as I said, you said right, it's hot, it can get very hot, it has sharp blades inside. So if someone is just handling with it and I'm starting it from remote, no, definitely not. But if it's on my local Wi-Fi network, it's already a bit safer, and from that on, it's a browser on one side, it's a Linux on the other side, so we can do so many things. You're welcome. If you have a good approach, we will implement it. We know that could be an issue. That's, of course, if you can do nasty things like that.
First, for the last question, get some hardware safety pins like blades off or blade only local. Just get a knob for this. Yeah. But how do you want to get with ingredients like habanero chilies and stuff like this, which are very every spice is different, you know? If you get pepper from this,
for the spices is difficult. I noticed I have a bug in my database when I wanted to add saffron, because I thought I take integral of grams. And with saffron I was already busted because even a pack is 0.4 grams. So no, there will be the very small quantities and the things that are to taste. I have a block that says add to taste. So you will still have to adjust it to have it fit. That's some human interaction is still needed.
Concerning the cleaning of the device, you have the possibility to heat, you have the possibility to stir, probably with a very high amount of rounds per minute. Why don't you just add a recipe for cleaning?
Yes, of course. I will try it out. So many ideas, so little times. Yeah, but of course. Yeah.
Okay. If I got it right, you plan or you have already done a lot on an open source hardware, software and data, all open project.
Yeah.
So can you tell a little bit more about your business plan? Like how would your investor make money or you would make money out of this?
In the beginning, certainly on the hardware side, until someone starts to copy me and give it away for a third of the price. Then I could go into a high quality segment and leave the cheap products to someone else. And yes, I didn't mention it, I'm not sure if it's in. I said for connecting people who eat and people who sell food, I would take some commission. But I want to keep a free limit, so I say it's below 10,000 euro a year as income. I could say it's free, so a very small farmer or someone who gives away his food would not pay. And if there's a big farmer making a lot of money with me, then we would just say to him, look, we brought you the customers, so give us a part of it. Then it gets a bit tricky how to prove, look, you made so much money with us. But I think if it's obvious, if he sees 80% of the traffic of my web shop come from everycook, and I just tell him, look, do you want me to turn it down? I think that we will find an agreement. And I think that's... I have to cover my hosting costs, so... And I think that will be even the more interesting part as soon as we get more and more hardware. That's why I want the hardware to be open. If someone makes just a scale or an oven or whatever, the more we have users, the more it gets interesting, we get more recipes, and that gives the possibility for the little farmer to sell his organic food easily without to have to deal with the big supermarket who rips him off.
We have 5 more minutes, so we have time for 2 short or 1 long question. Go for it.
Okay, hi. When I think of my recipes at home, I think I need at least 2 pots or 3 pots at the same time, or my first pot will be cold by the time the next pot is ready. Have you thought about networking 2 or more machines? Or maybe build an oven and network that too?
We want to connect all machines we can. If we take the everycook hardware as it is, a very multifunctional machine, I can't make it too cheap, so I'm price tag around 1,500 euros. Of course, you can put 4 besides, side to side, and make them talk together, but then it gets really expensive. So I thought you take everycook, make the most difficult part, and the web interface or the app tells you what you have to do on the other pots. For example, cook some rice or cook some pasta, and it takes care of the sauce. And in the last minute, you have to do the steak by hand, but the sauce won't stick. You just have 2 hands more, or 1 helper.
So you were talking about the timing for preparation of food so that everything can be done at the same time. Have you thought to have some sort of individual feedback? Because I know I can chop 2 kilos of onion very quickly, and whereas I know some other people who would probably take 3 times the time.
Yeah.
So.
No, we start with a rough estimate, but of course the interface when it tells you do this and you finish, you go to next, you skip.
Yeah.
But
will it remember for the next time, so that it will rescale my cooking for the next time? It knows that I can chop 3 onions in 30 seconds. And
this fits into the opportunities that digital cooking gives us. Learning, yes, we want.
Okay, thank you again, Alexis. That was wonderful.